Well, hey, TJ 8th graders, and welcome to your math e-learning video lesson here for today, as well as happy Bowtie Tuesday since it is Tuesday. We're going to get right into it. We're continuing Unit 4, which is about linear functions, and we're going to continue here with Lesson 3, which we're going to do two things. First, we're going to identify the slope, and then second, we're going to identify the slope given a graph, which is what you guys are going to be doing on your Math Excel assignment. And so let's start here by introducing slope. So slope is the measure of the steepness of a line. And so the letter we use to refer to slope is a lowercase m. So anytime you see lowercase m, you're thinking, okay, they're going to talk about the slope. So the slope here, sure enough, is equal to the rise or vertical change over the run or horizontal change. So it's a ratio or fraction of the rise over the run. And then if needed, like any fraction, you're going to simplify the fraction, as well as actually in this case, we're going to leave it as an improper fraction. We're never going to have it be a mixed fraction at all. And so let's start here with then talking about our strategy for finding the slope on a graph, and then we'll do some examples. So first step, you're going to pick 2 points on the line. Second, then, and third, you're going to count your rise and your run, with the rise being the vertical distance, keeping in mind positive goes up, negative goes down, and then for the run, or the horizontal distance, the positive goes to the right, and the negative goes to the left. And then we're going to finish by writing it as a ratio or a fraction. Once again, rise over run. You're going to hear that a lot. And then simplify if needed. And so let's go ahead and look at some examples of this. Now notice the first one, they actually already identified the points for us. So they did step 1. But notice what points they identified. So as we go along the line here, it's the point that went right through the grid lines, right through the middle of these 4 boxes. Now if you follow it, it kind of gets close a couple times to doing that again, but not quite. And so you got to be picky about this. Keep looking at it closely, and then finally up here, the same thing happens, which is where they marked another point. And so they've got our points here for us. And so let's now count the rise or the vertical distance. Now, you can start with either point, but I always like to do it just to keep it real simple and real easy. I like to always start with the point on the left. And so this point would be the bottom one here, in this case would be the one on the left. And so let's start there. Let's count up 1, 2, 3, 4, 5. And you can even draw it in here just to kind of visualize that. So we've got a vertical distance or rise of positive 5 since we're going up. And then the run here would then be going over 2, which is positive since we're going to the right, so over 2, and so we have our rise over our run. And so let's write the fraction then, 5 over 2, or 5 halves, and I can't simplify it, and it's an improper fraction, which actually in this case is perfect. So we got 5 over 2. Now let's do another one. So over here, we have to start by identifying the points. Now I noticed that right away, it's right there on -3. It goes through on the y-axis. That just kind of jumped out at me. So that's a good point we could use. And then if I follow it, once again, it gets close, but it's not all the way until over at 7, 1 that we actually go through the grid lines again. And now let's count here. Our vertical rise here would be 4, positive 4 since we're going up, and then our horizontal goes over 7, and so we would say this is 4 over 7. Can't simplify it. That would be our answer for the slope. Let's do 2 more. All right, here, once again, we have to start by identifying where are 2 points on the line I can use. This one jumps out at me right away. I noticed that up there on the y-axis, and then I also noticed one over here on the x-axis as well. And so let's go ahead and do our rise over the run. Now here, to get from the point on the left to the point on the right, I'm actually going down to. I'm not rising, I'm falling, which should kind of tell us something. And in this case here, it's that's not going to be positive, that's going to be negative this time. Since we're going down, that would be negative vertical distance, and then we're going over to the right, and so that would be a distance here of positive 4. And so we're going to have -2 over 4, and if you think about -2 fourths, that can be simplified to 1/2, in this case -1/2, and so that would be our answer, -1/2. Now this last one, we've got some kind of situation happening, but we still have a line, so let's find the slope of it. I notice it goes right through the y-axis there. I follow it over, there's another point it goes through as I'm following it along there as well. Now the vertical distance, I'm going to go down, but notice these numbers here. So it goes from 40, 30, 20. So even though this only goes down 2 boxes, it's actually going down a distance of 20. So make sure you would kind of factor that in. So negative 20 for our vertical, and then over is just going 0, 1, 2, 3. So there, I'm fine just to go ahead and mark that as positive 3. And so negative 20 over 3 here would be our slope for this one. Improper fraction, but that's fine, and I can't simplify it, so let's leave it like that. All right, lastly, we're going to finish here just with a couple patterns we noticed, as well as a couple special cases. So first, the patterns. So if you have a line that is going uphill or increasing, it ends up being that it's always positive. So if you notice the first slide we did, the first two examples, both of these were positive slopes, and sure enough, the lines were increasing or going uphill. And so that's always the case. You can always kind of double check your answer just to make sure if it's an uphill line, positive slope. And then on the opposite, or on the other hand, if it's downhill or decreasing, the line is, then it's a negative slope. So the second slide, both of our slopes were negative, and sure enough, both of our lines were going downhill. Now for a couple special cases. If you have just a flat horizontal line, that would be a slope of 0, because if you think about it, I mean, it's a horizontal line, like it's flat, like there's no steepness or slope to it, it's just flat. And so that would be a slope of 0, and that's because if you think about it, 2 points, there you would go over as with the run, but there's no rising. So rising, it would be a 0 over the run is some number. 0 divided by any number is 0. Okay, then lastly, no slope for vertical lines. So say it's like straight up and down like a telephone pole. It would be no slope or undefined, because if you had your 2 points there, and this time we're kind of flip-flopping this where we're able to rise some number, but the run is 0. And so we're, look at that, dividing by 0. So if you ever tried to plug that into your calculator and it's yelled and kicked and screamed at you that it can't divide by 0, once again, we can't do that in math class. So we have to say no slope or undefined, or we can't really give an answer for that slope in that case. And that's it for our video lesson here today.